So energy can like energy has too many forms actually. In uh, in general, we can divide it into two. Number one, renewable sources of energy, and the other is non-renewable sources of energy. The new renewable, from the name, it looks like something that we can use over and over again, but actually it means a form of energy that is available in abundance that will never run out. But non-renewable source of energy that we think that is available in scarcity, like there will be a time when it will run out. There can be two reasons for that. Number one, it is fixed and we keep on consuming it. And the second is that it is formed at a lower rate and it is consumed at a higher rate. So if something is formed at a lower rate and consumed at a higher rate, it is considered as a non-renewable source of energy because there will be a time when it will be completely run out. An example is coal and fossil fuel. Fossil fuel is something that is formed on Earth, but it has a very long cycle of formation, but it is consumed at a very high rate. That's why there will be a time when we will left with no coal or no fossil fuel over here. Now, mechanical energy. This is a type of energy that will be cooking more in this IGCSE syllabus. Mechanical energy can be classified into kinetic energy and potential energy. There is rotational kinetic energy as well, but that's not our concern right now because that is not part of the syllabus. Kinetic energy means energy of something because of its motion. Energy due to motion of a mass is called kinetic energy of the mass. How do we calculate kinetic energy? So it is kinetic energy is half mv square. Now, we'll go on next page. Kinetic energy equals to 1 over 2 m v square, and there are some restrictions over here. Mass must be in kgs, and it is not a choice like we can use grams or we can use kilograms. No, it must be in kilograms, and speed must be in meter per second. That will make kinetic energy in joule. So kinetic energy is half mv square, where m has to be in kgs. Now, potential energy.
Excuse me, sir.
Yeah. Gravity is a force, but gravitational potential energy is not a force. So this is how we can define or explain or state what gravitational potential energy is. Energy of a mass in a mass due to its position in a gravitational field is called gravitational potential energy. So what is gravitational potential energy? Energy of an object or mass because of its position in a gravitational field. Now, this is surface of Earth. If we make an object go up away from the surface of Earth, to do so, we need to work against gravity. This work is stored in object as gravitational potential energy. The, the energy that is stored in an object because of we are taking it away from the Earth's surface is known as gravitational potential energy. When we make an object go higher above the Earth, we lift an object away from the surface. In that case, gravitational potential energy increases because we are doing work against the gravitational field. And when something comes down, if this is an object, it is coming down like this. Then what will be the case? Gravitational potential energy decreases as work is done along the gravitational field. Now, whenever we do work in the direction of gravitational field, gravitational potential energy decreases. And if we do work against the gravitational field, gravitational potential energy increases. So what is the formula for change of gravitational potential energy? Change in gravitational potential energy equals to mg delta H. Units are very important. So height must be in meters. Gravitational field strength is in newtons per kg.
Newtons.
Mass is definitely in kgs. No choice. You cannot use grams or any other unit, milligrams, for example. And then change of gravitational potential energy will be in joule. Now, this is how gravitational potential energy is Then, now what about elastic potential energy? Elastic potential energy, also known as strain energy. Now, elastic potential energy is energy stored in an object, in an elastic object, due to deformation, is called elastic potential energy. Now, how many ways we can deform something? We have already done this when we were doing Hooke's law. How many different ways we can deform
Stretching,
something? We can stretch something, we
bend,
can bend something, we can compress something, we can twist something. So let me draw the diagrams again for you. So what has happened to this object? If the top diagram is the object when there is no force acting, and the bottom diagram is when there is a pair of forces is acting on the opposite side. So this object is what?
stretched,
Stretched. Now, this object is being compressed. This is compressed. Now, this object so this object is what?
bent,
This is bent. And for example, this object is like this. Now, in order to twist it, okay. I hope you can see that this looks like it has been twisted. So in all these cases, you have stored energy in the object. Let it go, it will go back to its original shape and size. And that this is what we call elastic potential energy. This is stored in an object because of deformation. Energy stored due to deformation is called strain energy or elastic potential energy. Okay. Now, there is no formula in your syllabus to calculate any of this, like stretching, compressing, bending, twisting. All you have to do is just explain that they are there, they are taking place. Okay. Now, energy converts from one form to another form. Law of conservation of energy. Energy is neither created nor destroyed. So we cannot create energy, we cannot destroy energy. This is not that simple. In later classes, you will understand that this statement becomes very complicated and very complex. But at your level, you can believe that energy is always conserved. So energy is neither created nor destroyed. The total energy stays same. But any particular form of energy can increase or decrease. Total energy is always same, but form of energy can change from one to another. For example, are you familiar with this thing that when we put a rubber band on our two fingers like this, and then place a slingshot here, and we try to hit somebody over there. Are you familiar with this thing?
Yes.
Yes, sir.
So this is called slingshot or catapult or so what we do is when we are stretching, we store elastic energy. When we let go, what happens? Elastic energy is being converted to
Inch.
kinetic energy because the paper bud that you have placed over here, there's a paper bud here. Now it completely depends on how much you like your friend, how much you love your friend. Like if you actually uh, like your friend a lot, you will definitely pull the rubber band a lot. Okay, how much you pull the rubber band depends on how much you actually want to convey the message across. So you stretch the rubber band and then let go. When you are stretching the rubber band, you are increasing elastic potential energy. But when you let go, elastic potential energy converts into kinetic energy. So if one starts argue with me, sir, you said that energy is never destroyed. Where is that elastic energy now? So believe me, Nobody said any particular form of energy is conserved. We said that the total energy is conserved, so it can convert from one form to another, from another to another, then another to another. So it keeps on converting. Let me give you an example. How many of you are familiar with a vault jump? In Olympics, sometime there is an athlete who starts running, and then he's holding a big bamboo, big stick in his hand, and when he comes close to the bar, he puts the stick in the ground, and then the stick pushes him up. He goes across the bar, flies down, and lands on an airbag. That is called a vault jump. See, I hope you're familiar with this thing. It is very.
Yes.
So I will steal this diagram from here. Okay, let's discuss it here. So total energy is conserved, but energy form can change from one to another. And here is an example for that. So what is going on? Let's see. Okay, there will be a time when this athlete will be at rest in the beginning. When? At rest. So when this athlete is at rest, this athlete has chemical energy for food. You know, food is a chemical. It burns inside your body at a very slow rate to produce heat energy. That heat energy can be used to maintain the body temperature, as well as it can be provided to muscles to generate kinetic energy or elastic potential energy. So now he's running. So when he's running, he's converting chemical energy to kinetic energy.
Kinetic.
So he is running till this third diagram. So what happens after in like fourth, fifth, sixth, and seventh diagram? Till seventh diagram, from 4 to 6, sorry, 4 to 7. Do you see that the stick, the vault or the stick over there is bending?
Yes.
So from fourth diagram to sixth, kinetic energy is converting into elastic potential energy as volt is bent, and when it bends, it stores elastic potential energy. So what is happening from 7 till this one? Like, let's say, what is this? This is 8, this is 9, this is 10, and this is 11. So what is happening from 7 to 11? From 7 to 11, elastic potential energy is converting into gravitational potential energy as the athlete gains height. So if he is gaining height, his elastic potential energy is converting into gravitational potential energy. So at 11, he has maximum energy. Now he will be falling down. So what will be happening here? Gravitational potential energy is converting into kinetic energy because he will be speeding up when he will be falling down. So, and when he is at the airbag, what happens to all the energy that we've been talking about? Question. What happens to all energy? Now, when he is like landing or staying on that mattress airbag, athlete strikes the airbag with maximum kinetic energy. All his or her kinetic energy converts to heat of air inside and sound. Okay. When athlete strikes the air bad it is, not bad. Sorry. Okay, when athlete strikes the airbag with maximum kinetic energy, all his her kinetic energy is converted into heat of the air inside the bag and sound. So everybody hears that large, loud sound, or smashing sound because the person falls on the airbag with a very high speed. So this is an example. Why I picked this example? Because it involves all the possible kinetic energies and potential energies that we are talking about when we started this topic. We were talking about what happens to kinetic energy, potential energy, and all of those energies, all three of them are involved over here. Actually, there is a chemical energy as well, the fourth one. Chemical energy converts converts to kinetic energy converts to elastic potential energy, elastic potential energy converts to gravitational potential energy, gravitational potential energy then converts into kinetic energy, and kinetic energy converts into heat and sound when heat uh, comes back to the air band. So I hope you understand. Any questions, anyone?
No, sir.
No.
So next topic is efficiency. What is efficiency? Efficiency is actually to study efficiency, we need to see this. Anything that converts energy from one form to another form is called a transducer. This is a transducer. So any form of energy that comes in just 1 second. This diagram has to be accurate. Let's say this is the form of energy that is coming in. So transducer is something that converts one energy to other form or forms of energy. For example, a lamp is a transducer because it converts electrical energy into light energy. Fan is a transducer because it converts electrical energy into kinetic energy. A heater, a gas heater or a stove is a transducer because it converts chemical energy into heat energy. Remember, all fuels are chemicals. Coal or petrol or diesel, they are all what? Chemicals. So chemical is converted into heat energy in a stove. Uh, a battery converts chemical energy into electrical energy. And a generator converts kinetic energy into electrical energy. A solar panel converts solar energy into electrical energy. So a transducer is supposed to convert one form of energy to another form of energy. Transducer can be a device, it can be a system, it can be a single object. Even a human being is a transducer because we can convert food, chemical energy into heat energy. So we are also a transducer. So anything that converts one form of energy to another form of energy is a transducer. This is input energy. Now the thing is that input energy and output energy are always equal because energy cannot be created and we cannot also destroy energy. So energy that goes in comes out. The same form of energy comes out. But the form that comes out is not all useful. No. Okay, now look, this is output energy. Remember, the total input and total output are always equal, but output energy is further categorized into two. One is useful form or forms of energy, and the other one is useless or wasted form of energy. Now, energy can be categorized into the form that we need and the form that we don't need. Nobody turns on a lamp to produce heat energy in the room. But if your lamp in your room, if your lamp has been turned on for a significant amount of time, if you touch it, you will find it uncomfortably hot. So you did not turn it on to produce heat energy. You turned it on to produce light. So the energy that we supply to that lamp, some of that is converted into light energy, which we need, and some of that is converted into heat energy, which we don't need. So this is how we decide what form of energy is useful and what form of energy is wasted. Efficiency is the ratio between useful form of energy and waste total input energy. Efficiency equals to useful output energy divided by total input energy. Now, if we are looking for the simple efficiency, then this will be the answer. But if we are looking for percentage efficiency, then we have to multiply this answer with 100. Okay. So this is the formula for efficiency. Any questions?
No, sir.
So we'll resume from the same point tomorrow. Till then, take care.
Allah Hafiz, sir.
Hafiz.
Hafiz.